This is the brief on Poison's flow and the parabolic velocity profile. So, what are we talking about? We're diving into something called Poison's flow. It's all about how pressure makes a fluid move through a pipe, and, it's a super important concept for everything from huge engineering pipelines to tiny medical devices. First up, the flow is governed by a simpler rule called Poisson's equation. It basically tells us that the fluid's movement depends on the pressure that's pushing it versus how sticky or viscous that fluid is. But here's the key part, the absolute rule you have to follow, the no-slip condition. It just means that any fluid touching the pipe wall isn't moving at all. It has zero velocity. Second, when you actually do the math, you get this really neat result, a parabolic velocity profile. So what's that? Well, it means the fluid moves fastest right in the center of the pipe, and then it gets slower and slower as you get closer to the walls. The math also shows us two really critical things. More pressure means faster flow, and more viscosity, a thicker fluid, means much slower flow. That's a huge deal for designing these systems. And finally, this isn't just theory. We've actually validated this with simulations and visuals. You can literally watch animations where particles zip along fastest in the middle and basically stop at the edges. It just proves that the math we did, it actually works in the real world. Ultimately, that parabolic profile is the defining characteristic of pressure-driven flow in a cylinder, backed up by both the math and what we can actually see.